All right, so standard error, S over square root of n, that's going to be 10.706 divided by square root of 12. So that we'll start with the outlier here. Um, okay, let's just get a oh, what the heck? I'll just use Excel. I've already been using here. So 10.706. Um, let's just get a new sheet here. All right. So equal sign 10.706 divided by square root. SQRT is the command for square root of 12. Okay. 3.091. 3.091. Okay, well that looks about right. My t-score is x bar 6.417 minus the null hypothesis, which is 0, divided by the standard error 3.091. Okay, and that's going to be, let's just go back to Excel here, 6.417. Well, 6.417 minus 0 is just 6.417 divided by 3.091. So that's about 2 point something. Okay, 6.417. Okay, equal sign 6.417 divided by 3.091. Okay, 2.076 equals 2.076. Okay, probably that means reject. Anytime your t or your z is greater than 2, it probably means reject. But let's look up on the table. Or well, since I've been using Excel, I might as well use Excel to get my p-value as well here. So 2.076. Back to Excel here. 2.076. I can do the tdist command here. Tdist 2.076 comma degrees of freedom is 11. One-tailed test. Okay, my p-value is 0.03 rounded off, or well, 0.031. All right. Now, of course, you can use the table as well. If you from the table, you would just find the two t-scores that are close to 2.076 and look down on the bottom row, and you would see that the p-value is between probably 0.025 and 0.05. Okay, which means reject the null because our p-value is less than alpha, and that's step 4. Okay, so there is evidence that the control limbs, the healing rate is lower, but the evidence maybe it's only lower because of the super newt there. They had the 31 in there. That's why the sample mean is so much higher than what the null is right here, is because of that 1 newt. Now I should point out that we did something naughty here. We shouldn't have even done this hypothesis test with an outlier because when your sample size is less than 15, our sample size is definitely less than 15, um, we have we should only have unimodal symmetric distributions. But we clearly had an outlier, so we shouldn't have even done this. But we did it anyways because it told us to in the book. But anyway, that's the analysis with, here, let's change colors here. So all that is with the outlier. So with the outlier, we rejected the null. Now, let's do the same thing without the outlier. So let's change to another, let's go to blue here. So with the outlier. Okay, so step 1, the hypothesis is the same. Mu equals 0, mu greater than 0. Here's our data without the outlier right here. So it's just a matter of redoing the calculations here. So S over square root of n is now going to be 4.182 minus 0. Or hold on here. Wait. Back up. Let's erase that there. I'm getting ahead of myself. I'm doing my t-distribution score here. So, all right. S over square root of n. I was looking at the wrong thing. So S, pardon me, is 7.756. Okay, S is 7.756. 7.756 divided by square root of n, which is now 11. And so let's just use Excel here for that. 7.756 equal sign 7.756 divided by square root of 11. So I'm just using Excel like a fancy calculator there. 2.339. 2.339. My t is x bar 4.182 minus the null divided by standard error 2.339. Okay, I can see I'm going to get a 1 point something now. So that's going to be 4.182. So equals 4.182 divided by, what was it one more time here? 2.339. Okay, 1.79. Or 1.788. Let's round up to 3 digits there. 1.788. So you can see, just because that one outlier was thrown out, our t is lower than before. Before, the t was 2.076. Now the t is 1.788. What is the p-value for that? So you can use the table again, but since I've got Excel, let me just go ahead and use it there. So 1.788. So equal t-dist 1.788. Degrees of freedom is 10. It's one less degree of freedom, one tail than before. So now p-value is 0.052. Okay, so it's still evidence, but it's not as strong evidence as before. In fact, if our alpha is 0.05, we would now say accept the null. So just with that one outlier, it made a difference between accepting and rejecting if the alpha was only 0.05. So so the bottom line here, let's go back to black here, is without the outlier, the evidence is weaker. Because the lower the alpha, the stronger the evidence, higher the the lower the p-value, the stronger the evidence. In this case, with the outlier, our p-value changed. It got higher, so it means it's weaker evidence here. So without the outlier, the evidence is weaker, which makes sense because it was the back to the raw data here. It was that back to our original sheet here. It was this guy, the 31, right there. Let's type it back in. That gave us such a high mean, higher than what the null would be. Without it, definitely this case is not so strong that that there's a difference between the two groups. And that is it for that question.